All right, class. So today we're going to do 4.3, which covers, so as you know, or as you might have, from previously, what we did was we went over all of these, right? So we've actually already done medians. We studied medians in 4.1. Those were the ones that connected midpoints to the opposite vertex. And so today we are actually going to be doing the angle bisectors. So we're going to do angle bisectors, perpendicular bisectors, just sort of a general recognizing of patterns. Okay, so we're going to do general recognizing of patterns that we hopefully studied, and kind of go with that. Okay, so the first one here is these are all angle bisectors, and as you know, if you have an angle bisector, let's zoom in here. If you have an angle bisector, then you have congruent angles, right? That's just something that you should know by now. All right. Then what I also did, so I just did the angle bisectors here. So your angle bisectors are in red, right? So we've got A to D, that's an angle bisector. C to D is an angle bisector, and so is B to D. Now what happens is, and you might not remember this, but when we were kind of studying it, what we noticed is that right here, this point in the center of the angle bicenter is that point D is called the incenter. Okay, it's called the incenter. Let me make sure I'm right with that. Yep, good. Like I said, I'm not going to make you remember these words, but it's kind of maybe something interesting to know. Why is it called the incenter? Well, it's called the incenter because it actually happens to be the center of the triangle, in the sense that if I drew a circle around the incenter, it would in fact actually just hit all of the edges, kind of like that circle right there. Since it hits all the edges, then these lines, the dotted lines, right? The dotted lines here, which we'll draw in purple here, these lines all are radiuses of the circle. And so since they're all radiuses of the circle, all the radiuses of a circle all also have to be congruent. Hopefully that makes a lot of sense. Okay, so let's start working around here. Fill in the measurements of all missing angles. Okay, well, this actually happens to not be that difficult because these are all angle bisectors. So since they're angle bisectors, I understand that, here we go, I'm going to zoom in here, this must be 36 degrees, right? And if that's 36 degrees, I notice that I have a right triangle here, and so up here must make it actually add up to 180, but since it's a right triangle, the two angles, this angle here, right, so this angle has to make this angle and this angle down there have to add up to 90. They have to be complementary. So adding up to 90 is going to be 54 degrees, so we're going to get a 54 there. Now, if you remember from yesterday, basically what actually happened, since we have this angle congruent to this angle, because they're angle bisectors, we have the right angle, right? So we got this right angle here. And we also note that obviously they share this side. This becomes angle side. So this triangle here and this triangle here must be congruent through angle side. So if they're congruent through angle side, that means this must be 54 degrees as well, right? So they have to match up perfectly. And that's going to be true throughout this triangle. So let's move over here to this triangle and this triangle, which again also have to be congruent. So since they're congruent, we immediately know this has to be 72 degrees. Well, if that's 72 degrees, then let's go down to angle A, or point A, right? And that has, since these are right triangles, we have to add up to 90. So 18 degrees and 18 degrees, since they have to be congruent. Now, we're left with these two triangles down here, right? Or up there. How are they connected? Well, they also have to be congruent. But we don't know any angles except for the right angle. However, we do notice that, let's just consider the triangle as a whole. If we consider the triangle as a whole, this large angle here at angle C is made up of two 36-degree angles, and so it must be a 72-degree angle. Angle A right here must actually is made up of two 18-degree angles, and so adding those together, this must be a 36-degree angle. In which case, since 36 plus 72 plus all of angle B, that all has to add up to 180. So what we do is we add 36 and 72. Looks like we're going to get a 108 plus angle B equals 180. And so angle B, in fact, when I subtract, is going to equal also 72. Right? Which is to say, although this doesn't look like it, but not drawn to scale or anything, which is to say then that the two angles, so what we do is we're going to take 72, divide that by 2, get 36. And so this must be up here 36 and 36, which means this over here is 54 degrees and 54 degrees. And that should complete all of our angle measurements throughout this triangle. Okay, let's go down. So that's how angle bisectors work, right? We can easily work our way all the way around the triangle, finding all of the missing angles. Give a quick explanation of why triangle AFD is congruent to triangle AGS. So that's actually the exact same explanation that I used over there, but let's just do it real quickly. So we know angle A is bisected, creating two congruent angles. We know that AD is congruent to AD. That's reflexive, right? So we've got this angle and this angle. We've got that side congruent to itself. And you can then also say, well, since we know the incenter, since we know D is the incenter, and the radius of a circle are congruent, we actually know that FD is congruent to GD. Because two radii of a circle are congruent. Thus, since we now have, right, we've got our two congruent angles right here. We've got those two sides. We got these two sides. We notice, though, as you go around this, if you just look at one triangle, we notice it's angle here, then a side, then a side. And so if it's angle, side, side, we don't have angle, side, side, remember. This does happen to be a right triangle, though. And so since it's a right triangle, we can say the triangles are congruent through HL. The three line segments that must be congruent are the ones in the center, because this is an in-center. So since this is an in-center, we know that DF is congruent to DE, which is in fact congruent to DG. All right, so that is the angle bisectors, right? We also have perpendicular bisectors we want to talk about. We have medians that we want to talk about. And there, again, are angle bisectors. So at this point, actually, you might want to go through and just do number 66, because number 66 is exactly like number 52. So why don't you go through, and given that those are all angle bisectors, why don't you fill in all of the angles, okay? So why don't you pause this video right now and fill those in. Okay, I'm going to now do perpendicular bisectors. Perpendicular bisectors, well, perpendicular, if you remember, create right angles. Bisectors, well, since this bisects the side, the bisectors actually create congruent line segments. Okay, so fill in the missing angles. So this actually kind of goes, so actually I'm going to skip 55 for right now. I'm going to do 56. Explain why triangle KMI is congruent to KMJ. Okay, so let's look at KMI. Here's KMI. So we're going to do K to M to I. So we're going to prove that that triangle right there is in fact congruent to this triangle right here. Well, let's go through. First thing is we have a perpendicular bisector, right? So perpendicular means this thing is a right angle. That means this is a right angle. So if I name these, we can just say, look, angle 1 is congruent to angle 2 because they are both right angles. Also, and that's because they're both right angles, formed from perpendicular lines, right? We know this thing is a perpendicular bisector, so those have to be congruent there. We also know it bisects, right? So since it bisects, that means this side here must be congruent to this side. So what do we know? We know IM is congruent to JM simply by the definition of bisect. Okay, so at this point, we've got one angle, one line. We need something else. That's actually kind of easy between these two. We notice, hey, look at that. KM is congruent to KM. That's reflexive, right? If that's reflexive, that's our 3, and our triangles are congruent. So triangle congruent to triangle through side, angle, side. So we know those two triangles are congruent. And I mean, that's going to be true with this triangle and this triangle, and that's also going to be true with this triangle and this triangle, right? So we've got 2 pairs of congruent triangles. Sorry, 3 pairs of congruent triangles. So 3 pairs of congruent triangles. Now, so let's actually go through this. Well, hopefully you're kind of getting the sense of how to do this from actually the angle bisectors. If that's 48 degrees, if this is 48 degrees, we must know that this is 48 degrees, right? So you can use that to solve for this angle down here and this angle over here, right? Then let's look at this triangle and this triangle. I see the 12 degree. So what other angle must be 12 degrees? They're both part of a right triangle. So you can actually figure out what this angle is and this angle is pretty easily. At which point you actually know most of the angles of the triangle, right? The only 2 angles that you don't know at this point are this one and this one. but you know the rest of them, and so you can actually add them all up, set it equal to 180, and figure out, well, this plus this must actually add up to the rest of the 180, and they actually have to be congruent, right? So you just divide by 2. So why don't you find all the angles, okay? Once you find all the angles, what sides are actually congruent? So number 57 here. So I'm going to erase a little bit of this in here, just because. All right, so what sides are congruent? So if I look at IM, what would be congruent to IM? Well, that's actually pretty easy because these are perpendicular bisectors, right? Bisectors, meaning if IM is 1/2, then the other half must be MJ, okay? So I'd like you to then complete 58, 59, and 60. Good luck. All right, one more thing. Medians. Now, I don't remember. Let's go back to the medians on the very front. It was like the first thing that we did in lesson 2. So if you remember correctly, in this median, check this out. Notice how the short side is always exactly half the long side, right? So the short side 1.7, that's half of 3, well, rounding error, that's half of 3.5. Or if I did 3.8, doubling 3.8 gives me 7.6, rounding error 7.5, right? So notice that the short side is always exactly half, right? Okay, so let's go back over there. So we're going to go to this one. So SU is 8. So where's SU? So if this is 8, this is the short side, right? So this right here is the short side, which means the rest of it, this side, must be 16. Okay? However, I can also give you the whole thing. For example, OT. Well, if the entire thing OT, that's from here all the way to there, that's 15, 2 parts are here, and 1 part is here. That's the way it's, 1 and then double it. Well, if 2 parts of 15 is here and 1 part of 15 is here, that's 3 parts. So what you actually want to do here is you actually want to take 15 and divide it by 3. That'll give you 5. That's the part. And now split it up into U and T, and then say, oh, well, 2 parts is O to U, right? So that's how you can kind of get those lengths. So I want you to see if you can do these lengths. Remember what a median is. But yeah, solve for the rest of these sides, and that will finish up your work. So please complete this whole thing, okay? All the way up to number 66. Yeah, be good to your sub. I don't know who it is. I forget. But hopefully you've been nice to them. Anyway, be sure to say thank you to them as you leave. And I will see you on Monday or Tuesday. Have a good one, class.